Welcome to Selector Packet Copilot. This is a beginner's guide on how to use this public, free, accessible tool to analyze packet captures with the assistance and augmentation of artificial intelligence. You simply upload your PCAP file, which is limited to 2 megabytes. The tool will analyze the data and store it in a vector store after transforming it into JSON, so we can do retrieval augmented generation to augment the generation of the output by retrieving packet information from the vector store. Should be noted that no data, including the PCAP, JSON, or vector store, is retained or stored. Everything is deleted during or after the session ends. But please make sure you follow your enterprise's internal artificial intelligence guidelines and governance models before uploading anything sensitive. Some general best practices and general approaches to get the most out of this tool. The smaller the file size, the better. The more concentrated the capture, the better. The less noise, the better. If you're a seasoned Wireshark veteran, you can use this as an augmentation to post-filtered captures. You can filter what you want and then apply the filtered capture to your upload here. It does not do well with very, very large files. There are diminishing returns with retrieval augmented generation. However, with small focused captures under 100 or 200 kilobytes, it does perform very well. Some other behaviors that I'd like to mention before we get started is that you can also use any language as your input. It really is a natural language interface, which allows you to interface with English, Spanish, German, Italian. It really is multilingual. So to get started, you can drag or drop or browse to the file, and I'm going to do a single packet. Now let's quickly take a look at what this looks like in Wireshark. This is a single packet that has a source and destination IP. It's a UDP protocol with a length and the various frame information and packet information. So we can ask it, what can you tell me about this packet? A broad, general question, an exploratory question. It's going to think about it and perform the retrieval augmented generation. And here is a detailed analysis of the packet based on the provided information. The general information, the frame number, the interface, the frame length, the Ethernet details, the IP details, the UDP details, and the data payload. So all the way up the OSI stack with observations and additional notes. Now let's do something a little bit more interesting. Let's try a DHCP packet flow. And we're going to look at this inside of Wireshark, where we have a discover, an offer, a request, and an acknowledgement. And this is a 4 packet or 4 frame flow. So again, we can ask the generalized question, what can you tell me about this packet capture? And it's going to do the analysis and actually come back and tell us that this is DHCP traffic, right? The packet provided contains DHCP traffic, which is used for dynamic IP allocation. And let's break down the details. So some general information, that there's 4 frames in total, all frames captured within a very short time span, indicating a quick DHCP exchange. The discover, the offer, the observations, and the conclusion. Now I can actually ask it, what is the DHCP server IP address? And it's going to come back with the actual IP address of the DHCP server based on the offer frames. So there's the IP. I'm going to ask it, can you please visualize this DHCP exchange in ASCII? And it's going to go ahead now and build an ASCII diagram of this DHCP interaction. So there's the discover and there's the offer in ASCII. Now I could actually ask it, can I please get a mind map of the 4 DHCP frames and highlight latency? So let's see if we can get a mind map of the 4 frames highlighting the latency between the interactions. So here we actually have the DHCP exchange mind map, frame 1, frame 2, and it highlights the latency, frame 3 with latency highlighted, frame 4 with latency highlighted. Latency observations, very low. Noticeable latency increase here due to the client processing time or the network delay. And then again low, showing a prompt server response. So the possibilities are really quite endless here. Let me quickly shift to a BGP packet. And what we're going to say here, we're going to quickly look up a Google Translate, since I don't have, and we're going to go from English, and we're going to say, what can you tell me about this packet capture? And let's go ahead and ask it in Spanish, just to prove that this truly is multilingual while retaining the ability to keep the domain-specific knowledge of packets and describe the BGP packets here in Spanish. So it does identify it as Spanish. Everything in the answers is fully Spanish, with little to no overhead or latency on the system. So it truly is a democratic approach, and we can do quite remarkable things. If you're coming here from a security perspective or have security curiosity, let's take a look at an infected slammer worm packet and say, are there any security concerns in this packet capture? So I simply provide the packet and ask if there's security concerns. And here are the security concerns. The port number is 1434, commonly associated with SQL Server Resolution Service and historically targeted by the SQL Slammer worm. The presence of the remote procedure call protocol and some Kerberos authentication verifier. And then some security recommendations on how to mitigate against this type of malicious traffic. Let's actually try another packet flow. This one's going to be a teardrop attack. So I'm going to actually ask it directly, are there any indications of a teardrop attack in this packet capture? And it should find that there's the presence of an overlapping fragment. So yes, potential teardrop attack detected. The presence of overlapping IP fragments in frame 9 suggests a possible teardrop attack. Now, some other things that we can do, if we're, let's say, new to the field and want to use this as a training tool, Here's a packet capture that represents EIGRP. And I'm going to say, can you please explain this packet capture like I'm 5 or studying for my CCNA or Network Plus exam. We're going to go ahead and send this EIGRP packet and use the augmentation to help educate us about what's happening here. What's happening here with a nice thinking face emoji. And it actually talks about this as using a special language called EIGRP. So the protocol, the source and destination, the MAC address, the message, the time to live, any anomalies, some key takeaways for your exam, all from the packet capture with real information. So I urge you to try this from a variety of perspectives, and please do keep in mind the limitations of the current technology, meaning the size of the packet capture, as well as trying to use this as an augmentation, not necessarily a replacement for a tool like Wireshark. We do encourage your feedback. We would love to see your use cases and see any emergent behavior that you discover that I may not necessarily have thought of. So thank you again, and enjoy chatting with your packets.